So today we will continue from where we left off yesterday. We will learn about between two curves, and then moments and center of mass, and then volumes using cross sections, and volume using cylindrical shells, and then finally integration by parts, or integration by parts, or I think you know it high school by the name integral partial. Okay, now the area between curves. So basically, if we want to compute the area, we have to make sure that the integrand, the function here, is positive. So in this case, we can well, we are sure that this is positive because a square root is always positive in this case, and square x squared will always make set here we set u to be equals to x cubed plus 1, then we can take du as du dx times dx, which is 3x squared dx. Then in this case, by substitution, we have that the integral is now becoming integral of square root of u with respect to u. Then the integral is just 2/3 times u power 3 over 2 plus a constant c. Yeah, if we substitute back the u, then we will get this guy. Then after that, to compute the definite integral, then since we already know the integral, we have that the definite integral is now becoming this, yeah, 2/3 times x cubed plus 1 power 3 over 2 from -1 to 1. And then we simply substitute the upper limit, then minus the lower limit. Yeah, this is from the second fundamental theorem of calculus. And we get that the value is 4 over 3 times the square root of 2. Jadi di sini untuk mengintegralkan ini, ya, definite integral ini, pertama kita cari dulu integralnya supaya mudah, ya. Dengan permisalan, ternyata kita dapat integralnya ini, ya, kalau bentuk umumnya pasti ada plus c. Kemudian setelah kita dapatkan integralnya, kita tinggal masukkan batas bawah dan batas atas. Kita pakai teorema dasar kalkulus yang kedua. Jadi kita masukkan batas atasnya dikurangi dengan dengan batas bawahnya. Selesai. Any question for this example? Any question?
Pak, berarti itu,
Yeah.
Sorry, so that must be the basic, it must be 1 minus 1. Itunya pasti si yang dari teorema dasar kalkulusnya itu yang tadi 1 min 1.
Kita masukkan batas atasnya,
ya,
1
batas
ya,
atas bawah.
x, kemudian dikurangi dengan x pangkat 3 plus 1 pangkat 3 per 2 dengan batas bawah x1 ini.
Yaitu selalu 1 pasti kan, Pak?
What do you mean? For this part?
Yeah, for this part it must be 1, but for another question maybe it can change, right?
Yes, it depends on what the lower limit and upper limit is. Ya. Jadi ini tergantung limit batas atas dan batas bawahnya apa. In this case, we have that the lower limit is -1 and the upper limit is 1. Ya. Karena kebetulan di sini batas bawahnya adalah -1 dan batas atasnya adalah 1. Any other question?
No, I think no.
Now, the definite integral of symmetric function, yeah. So if you even and odd function from our first week, apa fungsi ganjil dan fungsi genap dari pertemuan minggu pertama, ya. So if we have is even, then if the interval is symmetric from minus a to a, then we know that the integral can be rewritten as integral, ya, 2 times integral from 0 to a fx dx. And if f is odd, ya, kalau f-nya fungsi ganjil, then if the interval is symmetric, ya, from minus a to a, kalau intervalnya simetri dari minus a ke a, then we know that f of x dx is always 0. For example, this function, so this integral, we have that f of x is x power 4 minus 4x squared plus 6. Then in this case, we have that the function is even, yeah, because if we put f of minus x, the function remains the same as fx. Jadi ini adalah fungsi genap, karena kalau kita ganti x-nya dengan minus x, maka minus x pangkat 4 adalah x pangkat 4, ya, karena negatif pangkat genap itu negatif menjadi positif, and so on. Then we have that the function is even. Then since we are asked to compute the integral on symmetric interval to 2, and in this case we can just compute the integral from 0 to 2 and multiply the definite by 2. Any question for this example?
Sir, itu kenapa tiba-tiba jadi from 0 to 2?
Yeah. This is because the function is even. Ya, karena fungsinya adalah fungsi. Okay, let me illustrate it in a picture. Yeah. So, even function. So we have this. Let's say we have this kind of curve, yeah. Or we have this kind of curve. Or we have well, any kind of curve that sorry, this is x, fx, or let's say we have this kind of curve. You see that the area here, they are equal. The left one is red and the right one is blue. You see that the area between the red one and the left one, they are equal. Jadi kalau fungsinya genap, ya, luas yang sebelah kiri ini 0, ya. This is 0. Luas yang sebelah kirinya x sama dengan 0 itu sama dengan sebelah kanannya x sama dengan 0, ya. Jadi, ya, on the left and on the right they're the same. Then in that case, instead of this is from minus a to a, yeah, minus a to a, also from minus a to a. Since we have the same interval, symmetric interval, yeah, from minus a to a, then the area, the red one and the blue one, they are the same, they are equal, then instead of integral of minus a to a fx dx, we can just compute it as 2 times integral from 0 to a fx dx ya. Ya, jadi karena intervalnya simetrik ya, dari minus a sampai a, dan kita tahu bahwa kalau fungsinya genap ya, mereka luas yang di sebelah kirinya sumbu y dan sebelah kanannya sumbu y itu sama, maka daripada kita menghitung integral dari minus a sampai a fx dx, kita bisa cukup menghitung salah satu luasnya saja, yang sebelah kirinya saja atau yang sebelah kanannya saja, sehingga integral kali integral 0 sampai a fx dx. This is even function. Odd function. Odd function. If we have odd function, then function look like this. X fx, then the function might look like this. From minus a to from minus a to a, yeah. Then in this case we have that this red one and the blue one, they are the same, but the value would be different. In this case, we have that if the function is odd, then integral of from minus a to a f of x dx is equal to, let's say we split them into minus a to 0 fx dx plus integral from 0 to a fx dx, yeah. And since we know one is on the lower half plane, then the value of the integral is the negative from 0 to a fx dx. So we have here plus 0 to a f dx, which is equal to 0. Jadi kalau fungsinya ganjil, karena kita punya fungsi ganjil itu seperti ini ya. Sorry, let me write it. Okay. Even function is if f of minus x is equal to fx. Odd function is if of minus x is equal to minus of f of x. Sehingga ketika kita mencari integralnya ya, maka yang merah ini luasnya sama dengan yang biru, tapi bedanya yang merah ini karena kita integral bias tidak mencari luas, yang merah ini nilainya negatif, yang biru nilainya positif. Besarannya sama ya, karena besarannya sama maka mereka saling menghilangkan, maka nilainya, kalau yang fungsi genap yang di atas ya, itu besarannya sama tapi mereka tidak saling menghilangkan, jadinya ditambahkan malah 2 kalinya. Is it clear now?
Clear, sir.
Okay. And now we go to the next one. Yeah. Find the area of the region enclosed by the parabola y equals to 2 minus x squared and the line x y equals to minus x. Okay, for this one, if we draw y equals to 2 minus x squared, y equals to minus x squared and y equals to minus x, yeah. So if we draw it, we just draw it here. F of x is 2 minus x squared and g of x is minus x, yeah. So if we plot f from minus 2 to 2, plot g from minus 2 to 2, yeah. Oops, sorry. Oh no, from minus 1 half to 2 half. Yeah. Then now we want to put here the plot. So here here we have the blue lines is this is y equals to minus x squared, and the red line is y equals minus x. So what we want is to compute the area. Let's use green. We want to compute the shaded area. So basically what we want is we want to compute the area between the curve 2 minus x squared and minus x. So the first step is by finding the intersection point. So we have that the limit of integration. Since the area of the region enclosed by the parabola and the line, yeah, that means the shaded area, the green ones, the green area. Then the limit of integration is found by solving 2 minus x squared equals to minus x, which in this case we found that x is minus 1 or x equal to 2, because they have to be equal, which at this intersection point, yeah, this is x minus 1, x equal to 2. Then finally we can compute the integral, yeah, where this is upper curve, and so basically we integrate from x minus 1 to x equal to 2, yeah. The limit is from minus 1 to 2, from minus 1 to 2, yeah, here. Then the integrand is the upper curve minus the lower curve, yeah. So we have 2 minus x squared minus x. Because the upper curve is 2 minus x squared and the lower curve is minus x. We integrate with respect to x, then we finish the integration. Any questions? Example?
I think no, sir.
Yeah. The others? No? Then if not, let's go to the next example. So in this case, this example, sorry that the picture is too small, yeah. But I think if we unlock this, it is still too small. Okay. So here we want to find the area of the region in the first quadrant, yeah, that is bounded above by y equals to square root of, and below by the x-axis and the line y equals to x minus 2. So the limit integration, yeah, again we found by finding the section points, yeah, which in this case we make y equals to square root of x and the line y equals to x minus 2 equals. So here we find that the x that satisfy this equality is x equal to 1 or x equal to 4. But since at x equal to 1, the intersection point is below the first quadrant, it's actually on the fourth quadrant, we don't include it, yeah. So we only include, since we only considering the first quadrant, we see that y equals to x minus 2 is greater or equal than 0 if x is greater or equal than 2. Then in this case, the intersection point is only at x equal to 4. Karena kita hanya mencari di kuadran pertama, maka titik bertemunya hanya ketika x-nya sama dengan 4. Karena garisnya harus lebih dari sama dengan. We draw the both curve like this, yeah. We draw the curve like this, and we see that on the first one, the curve looks. Jadi kita gambarkan apa namanya kurvanya di kuadran pertama, ya. Ternyata kita melihat bahwa kurvanya bentuknya seperti ini, ya. Yang biru adalah y sama dengan akar x, ini ada penandanya. Yang kuning adalah y sama dengan x min 2. Then in this case, how should we find the area? Because in the previous case, yeah, in this case we have that the curve Well, the limit of integration from -1 to 2, well, the area, the green shaded area, is always enclosed by the two curves. But in this case, we have that somehow before x equal to 2, yeah. So x from 0 to 2, bound is from square root of x. Yeah. The upper bound is square root of x and the lower bound is x-axis. Nah, jadi ini dari 0 sampai 2 x-nya. Batas atasnya adalah akar x dan batas bawahnya adalah sumbu x. And from 2 to 4, the upper bound is a square root of the lower bound is the line y equals to x minus 2. So in this case, we split the region into two area, yeah, which is A and B. In this case, we have that the area A is integral from 0 to 2 cos square root of x dx plus area of B, which is integral from 2 to 4. Since we have two curves here, square root of x minus 2 dx. Any question for this example? Ada pertanyaan? Is it clear?
I'm still mengolah, sir. I a little bit confused when the 2 per 3 x 3 per 2 minus x2 per 2 yang integral 4 per yang integral nahnya itu.
It's integral.
Ya.
This is the integral of this. Jadi ini integralnya ini ya.
Itu yang itunya ya, sir. Kalau di graf itu yang biru ya?
Yes.
Oke.
Here I wrote it clearly. A, the total area is the area of A plus the area of B, and the area of A is integral from 0 to 2 square root of x dx, and the area of B is integral 2 to 4 this integral.
Nanti kita
Any
itu
other question? Yeah.
diarsir, biasanya diarsir nggak?
Ya.
Oke.
And we see that actually, in this case, if we want to integrate with respect to x, we need to split the area into two areas. Karena kita ingin mengintegralkan terhadap x, ya, maka kita perlu membagi luasnya menjadi dua bagian. But actually, we can try to find the area by integrating with respect to y. Jadi kita bisa mencari integral dengan mencari luasnya dengan mengintegralkan terhadap y. In this case, we have that the upper function is the yellow lines and the lower function is the blue lines. Ya. Jadi karena di sini kita bisa juga mengintegralkan terhadap y. Ya. Batas fungsi yang atasnya adalah fungsi yang garis warna kuning dan fungsi bawahnya adalah yang warna biru. Why? Because at this point, the value of x is on the yellow lines is always greater than or equal to the value of x at the lines. Jadi di sini karena nilai dari x di garis kuning itu selalu lebih besar daripada nilai dari x di kurva yang warna biru, maka fx-nya adalah yang atas ini ya, yang x sama dengan y-2, y plus 2, sorry. And then the lower function is x y squared. But now the limit, since we want to integrate with respect to y, the limit becomes from 0 to 2. Jadi kita bisa dengan cara yang lain ya, yaitu di sini kita kalau tadi kita integralkan terhadap x ya, sekarang kita integralkan terhadap y, ternyata kita tidak perlu membagi areanya menjadi dua area. So, in this case, di dalam kasus ini, proses menghitung luasnya jadi lebih mudah, karena kita cukup mengidentifikasi mana fungsi yang atas ya, fy, dan mana fungsi gy. Ternyata fungsi yang atas adalah, kalau y-nya di fungsi yang atas ini maksudnya adalah fungsi yang paling kanan ya. Dan gy ini adalah fungsi yang paling kiri. Fungsi yang paling kanan adalah garis kuning, yang paling kiri adalah garis biru. So for this example, any question? Any question?
I think no, sir. It's clear.
Now, we want to do this, yeah. Evaluate the first one. For A, yeah, let u equals to y plus 1, then we have that du equals dy. So integral of 0 to 3, sorry, without the limit first, yeah, integral of square root of y plus 1 dy is actually integral of square root of u du, which is integral of u power half du, which is 2/3 u power 3/2 plus c, which is 2/3 square root of y plus 1 power 3. So integral from 0 to 3 of square root of y plus 1 dy is actually 2/3 y plus 1 power 3. We take the square root from 0 to 3, yeah, which is 2/3 of square root of 4 cube minus square root of 1 cube, which is 2/3 multiplied by 4 cube square root is 8 minus 1, so this is 14/3. And for b, we have that integral from minus 1 to 0 square root of y plus 1 d is equal to 2/3 square root of y plus 1 cube from minus 1 to 0, which is 2/3 square root of 1 cube minus square root of 0 cube. So this is 2/3. And this one integral of 3 cosine squared x sine x dx is basically integral of minus integral 3 cosine squared x d cos x, which is minus cosine cube x plus c. Here we let this u equals to sine x, then du is actually sorry, not sine but cosine of x, then du is actually minus sine x dx. So for we have that integral from 0 to pi 3 cosine squared x sine x dx is minus cosine cube x from 0 to pi, so minus cosine pi cube plus cosine pi plus cosine 0 cube. So we have 1 plus 1 plus 2. Cosine of pi is equal to minus 1. And for b, we have integral from 2 pi to 3 pi of 3 cosine squared x sine x dx is equal to minus cosine cube x from 2 pi to 3 pi, which is minus cosine 3 pi cube cosine 2 pi cube, which is again cosine 3 pi is minus 1, cosine 2 pi is 1, this is cosine 0 is 1, so we have equal to 2 again. Yeah. Then this guy for this guy, this is easy, yeah, because we have that y is an odd function because f of minus x, yeah, which is minus x square root of 4 minus x squared is equal to minus x square root of 4 minus x, which is equal to minus of fx. Then integral from minus 2 to 2 of x square root of 4 minus x squared dx is equal to 0. Up to this point, any question?
Sir, saya mau tanya.
Ya.
Itu kenapa berubah jadi f min x, kenapa nggak fx?
Nah, okay. Okay. Here we have that fx equal to y equals to x times 4 minus x squared. And we want to check whether the function is odd or even. Kita mau cek apakah fungsinya ganjil atau genap. Maka kita cek dengan cara memasukkan minus x. Ternyata kita dapat f minus x adalah minus fx ya. Kita balik ke atas lagi. Kalau f minus x adalah minus fx, maka fungsinya adalah fungsi ganjil. Minus x adalah fx, maka fungsinya adalah fungsi genap. Then since we know that the function is a function, the integral, if the interval is symmetric, then the integral is always 0. Yeah. Is it clear now?
Yes, sir. Thank you.
Any other question?
No, sir.
Find the area of the region by the lines and the curve below. It's always taking finding the limit integration. The integration we find by x squared minus 2 equals to 2. Then in this case we have that x squared equals to 4. Then is plus minus 2. And we know that if x is between minus 2 to 2, we have that two is always greater or equal to x squared minus 2. X squared minus 2, 0 squared minus 2 is minus 2. Then we have this, yeah. Then in this case, we have that the area is the integral from minus 2 to 2 of 2 minus x squared minus 2 dx, which is integral from minus 2 to 2 of 4 minus x squared dx. Yeah. And in this case, we know that 4 minus x squared is even because because 4 minus x squared is equal to 4 minus x squared. Then in this case, we can just compute 2 times 0 to 2 of 4 minus x squared dx, because the limit integration is symmetric, yeah, from -2 to 2. Then we have here 2 times 4x minus x cubed over 3, 0 to 2, which is 2 times 4 times 2 minus 2 cubed over 3, which is 2 times 8 minus 8 over 3. Here we have 32 over 3.
Sir, can you go up a little bit? Yeah.
Jadi di sini prosesnya adalah kita mencari titik temunya, ya, intersection points, dengan membuat x kuadrat min 2 sama dengan 2, kemudian kita dapat bahwa x-nya adalah dan min 2. Dan kita cek di antara min 2 sampai 2, yang mana yang lebih atas. Ternyata 2 selalu lebih besar dari atau sama dengan x kuadrat min 2 di x dari min 2 sampai 2. Maka luasnya adalah integral min 2 sampai 2, fungsi atasnya 2, dikurangi fungsi bawahnya adalah x kuadrat min 2 dx. Integral dari min 2 sampai 2. Di sini kebetulan fungsi 4 min x kuadrat adalah fungsi, maka kita bisa pakai aturan fungsi genap, ya. Kita cukup menghitung separuhnya. 2 kali integral 0 sampai 2 4x kuadrat 4 min x kuadrat dx. Kemudian kita dapatkan hasil akhirnya. Any question? No?
Oh iya, sir.
Ya.
Itu kan jadi integral titik bawah 0 titik bawah 2 itu dari integral min 2 itu ya, sir? Min 2-nya dikebawahin. Enggak dikatasin ya?
Dari integral min 2 sampai 2, ya, karena integralnya simetri batasnya. Maksudnya apa? Kalau dari 0, 0 ke 2 jaraknya berapa?
2.
0 ke min 2 jaraknya berapa?
0 ke min 2 itu
Jaraknya 2 juga kan, ya?
2.
Karena jaraknya sama ke 0, maka kita bisa bilang simetri. Maka kita bisa pakai aturan yang di atas ini tadi, ya. Kalau fungsinya genap, maka integral dari minus a sampai a fx dx adalah 2 kali 0 sampai a fx dx, karena alasan gambar ini.
Oh iya.
Here we see that the function 4 minus x squared is even function. So we have that we can. Is it clear now?
Yes, sir. It's clear.
Any other question? No. Okay, now this is the last this is the last slide, yeah, for this sorry, the last questions for this slide. So if we draw the picture, x, y, yeah, x equal to 2y squared. When x equal y equal to 1, x when x equal when y equal to 2, x equal to 8. When x equal to 3, y equals to 18. Well, let me scale it down, yeah. So here, and I think here 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, here. So here 1, 2. This is 8, 2, 3. So the curve looks like this. And the area is enclosed by the lines and curve below. Yeah. So basically the area we have enclosed by this is y equals to 3, and here x equal to 0, and the curve equal to 2y squared. Yeah. So basically the area is this guy. Then in this case we can use the area. We can compute it by area equals to integral from 0 to 3 to y squared dy, which is y cubed from 0 to 3, which is 3 cubed, sorry, 3. Okay, this is 18. Or we can also compute the area by this way, yeah. Integral from 0 to 18. The upper function is 3, and the lower function is y equals to 1 over square root of 2 x power half dx, which is 3x minus 2 over 3 square root of 2 x power 3 over 2 from 0 to 18, yeah, which is 3 times 18 minus 2 over 3 square root of 2 x square root of x power 3 anymore, but it should be 18. Here we have that 3 times 18 is 36 plus 18 is 54. Hope that I'm correct, yeah. And then minus 2 3 square root of 2. We have here 3 square root of 2, yeah, power 3. So here we have here the power becomes 2. So we have 4 minus 2 times 18. 18. The result must be the same. Yeah. Any question for this example? Any question? No? Is it clear?
Yeah, this is clear.
Now we go to the next slides for some moments, yeah, because the topic is about moments and centers of mass. Basically, this the formula. Moments about x-axis is basically integral of y tilde dm, and moments about y-axis is actually this my, which is integral of x tilde dm, and the mass is integral of dm, and center of mass is basically at x, the center of mass x bar is my over m, and y bar is over m. So for example, if we have a triangular plate enclosed by y equals to 2x, y equals 0, and x equal to 1, and we assume that it's a constant density of delta, which is 3 grams per centimeter squared. Then we are asked to find the plate's moment about y-axis, the plate's mass about the plate's mass m, and the x-coordinate of the plate center of mass. I will just show you the illustration of the picture. The first method is by using vertical strips. What does it mean? So if we have the picture like this, the curve, the graph like this, x, y equals to 2x with x, y 0 and x 1. Yeah. So the boundary is y 0 and x equal to 1. This is x equal to 1. Sorry. And here is y equals 0. And bounded again by the y equals to 2x. Y equals to 2x. So we have the plate to be this shaded green plate. Use this shade. What does it mean by these vertical strips? Basically, what we do is take okay, so we take this vertical strip like this. It has this distance, yeah, x, and the center of mass is always in the middle of this vertical strip. Yeah, which is here in this case we have half of y, which is half of 2x, which is x. So that's why we have that the center of mass is x tilde comma y tilde, yeah, which is x comma x, yeah, because we have x comma x. And then the length of the vertical strip is 2x, with the width the width is basically this small width. This is the width. This is dx, yeah, dx, and the area of the vertical strip is basically dx multiplied by of the area dA is dx multiplied by 2x. Here we have dA equals to 2x dx, and the mass, yeah, dm, is basically the density delta times area, which is 3 times 2x dx. So here, from here, we find that the moment of the strip about the y is x dm is basically 6x dx, and if we want to compute the moment of the plate, yeah, here is just the moment of the strip. The moment of the strip is 6x squared x. But since we want to compute the moment of the plate, take the integral from the strip. From we move the strip from the left to the right. Yeah. So here, integral from 0 to 1 of x tilde dm, which is x tilde dm, we have that x squared dx. We have integral from 0 to 1, 6x squared dx, which is 2 gram centimeter. This is the of the plate about the y-axis, and the plate's mass is integral dm. We have that dm is 6x dx, and the integral remains the same from 0 to 1. We find that the mass is 3 grams. Therefore, the coordinate of the plate's center of mass, x bar, is my divided by m, which is 2/3 centimeters. And we can also use horizontal strips, which is a little bit different. Now, if we use the horizontal strips, the picture becomes So if we use the horizontal strips, then the picture becomes like this. X, Y. Let's draw using the same color. This is y equals 0 and x equal to 1. The blue lines is y equal to 2x, yeah. Or we can also write it x equal to half of y. So here now we want to take the horizontal strips instead. In this case, what we do is we take this horizontal strip and the center of mass is here, yeah. We have that the position of the center of mass is now okay. This dot is in the middle. We have that the position of the dot is this dot is basically 1 minus half, 1 plus half of y divided by 2. Or here we have 2 plus y over 4. Yeah. So in this case, this part is 2 plus y over 4, while the height is y. And here we have this part is dy. Yeah. Now, if we use the horizontal strip, this is wrong. Yeah, I forgot. It should be horizontal strip. The data is the center of mass is x tilde. Yeah. X tilde is 2y minus 4, 2 plus y over 4, and y tilde is y with the length of this guy. The length of the strip, let me use a different color. This length is 1 minus half of y, which is 2 minus y over 2. 1 minus half of y, with the width of the strip is dy, and the area is dy multiplied by the length. So 1 minus y over 2 dy times 1 minus y over 2 times dy, so that the mass now becomes like this. Yeah. And we can compute the moment of the plate about the y-axis is now like this. Yeah, we have different kind of integration, but the results remain the same. We still have 2 grams centimeter, and therefore also the plate's mass we have 3 grams, and therefore the center of mass, the x coordinate still remains 2/3 centimeters. Yeah, either the vertical strips or horizontal strips, the results must be the same. Any question? Ada pertanyaan? No? And the formula is basically like this, yeah. So the previous example here, what I show you is how we get the formula, and basically the formula is in this slide. Yeah. So the moment of the plate about y-axis my like this, x times delta times x minus g of x dx, and about x-axis is integral from a to b delta to f squared minus g squared dx, and the center of mass, the coordinates is this guy. Ya, jadi apa namanya, rumusnya ini ya. Kalau kalian tidak mau ribet-ribet menggambar seperti ini ya, rumusnya ada di sini. Dan kita adalah kalian harus ingat bahwa fx ini selalu lebih besar daripada gx ya. Jadi fx selalu di atasnya gx. For example, center of mass for the thin plate bounded by the curve gx equal to x2 and fx equal to square root of x from 0 to 1 with the density function delta x equal to x squared. First, we compute mass of the plate. Ya. Rumus masanya adalah yang bawah ini ya. M is integral dm, which is integral from a to b delta times gx dx. So, integral delta times fx minus gx dx. So integral is from 0 to delta is x squared, and we have that from 0 to 1, fx is always greater than or equal to gx. Dari 0 sampai 1, akar x itu selalu lebih besar daripada x per 2. That's why we have that fx is x and gx is x over 2. Yeah. Then we simplify them and finish. We get that the mass is 9 over 56. And then we compute the moments using this formula. Moments about y-axis, the top one, is 11 over 90, and moment about x-axis is 1 over 10. That's why we get that the center coordinate of the center of mass is given by this moment about y-axis divided by m for the x bar, and moments about x-axis divided by m for y bar. For this example, any question?
Sir, tapi nanti
Yeah.
ketika UTS we need to draw the graph also, right?
No.
No.
You can directly use this formula.
Okay.
Ya.
Thank you, sir.
Jadi kalian bisa langsung pakai for group. Kalau gini, kalau kalian mau menggambar, boleh. Tapi kalau kesulitan ya, menggambar karena malah bingung apa namanya, takutnya malah bingung menentukan ini titik-titik yang seperti ini, ya, maka kalian tinggal pakai rumus ini. Ya. Kalau dilihat ya, yang di sini, ya, yang di contoh pertama ini ya, atau kalau kita lihat rumus ini dengan kita bandingkan dengan gambar ya, fungsi yang atasnya untuk yang vertical strip itu yang ini ya, rumus ini adalah rumus yang vertical strip ya, bukan yang horizontal strip. Jadi ini adalah rumus yang vertical strip, tapi nggak apa-apa, kalian cukup tahu yang ini dulu ya. Kita lihat bahwa yang atasnya adalah 2x, bawahnya adalah y sama dengan 0 ya. Maka kita punya kita hitung ini ya, vertical strip. Atasnya adalah 2x ya. Kemudian deltanya 3 ya, 2x kali 3 berarti 6x. Kemudian dikalikan dengan x ya. X kali delta kali 2x min 0. Jadi kita dapat bahwa integralnya adalah integral 6x kuadrat, sama saja ya. Any question?
I think no, sir.
If not, then I ask but okay, I ask you to read this example before our next session, yeah. And we will start from this example after well, in our afternoon. Then we will directly go to the classroom challenge, yeah. So let me end this morning session. See you in the afternoon. And this, Assalamualaikum.